Students, we are studying lesson number 5 and name of lesson is there heat. So in case of the heat lesson, today we are going to study new concept, and in that first one is there regulation. So what do you mean by regulation? First with the help of some examples we'll see that one. So one thing you are doing, or in the summer season you are eating ice ball. In the summer season you are eating ice ball. So how that ice ball is prepared? How that ice ball is prepared? So one slab of that particular ice slab is taken, and that ice slab is shredded. It is shredded into pieces. It is shredded into pieces. It is shredded into pieces, and then it's shredded into pieces, that small pieces, and after that you are taking one stick, and to that stick these pieces of the shredded pieces of that particular ice, these are pressed, and after pressing you are getting ice ball, and in that colors are mixed. So how this happens? So first thing, you are taking ice slab, you are shredding that one, you are getting pieces, and then these pieces are pressed, and you are getting ice ball, and you are eating ice ball. So how it occurs, this one we have to study today, and it comes into the regulation. So in case of the regulation, to understand that regulation, one experiment short activity is given, and in that what you have to do, one table you are going to take. On that table you have to place one ice slab you have to place, and two equal weights you have to take, two equal weights. So, and one wire you have to take, one metallic wire you have to take, and you want to hang that particular metallic wire over that particular ice slab. So what will ice slab or ice cube, then what will happen when weights are applied? This wire will pass through this particular ice and it will come out. Wire will pass through the ice and it will come out. So finally it will come out of the ice slab, but this ice slab will not get divided into two equal parts. So this ice slab will not break. But why it is happening? There is a reason we have to see. So what happens? This activity in this ice slab is not breaking, so it is called as a regulation. But actually what happens here? Actually what happens here, and that one we have to see. So when pressure is applied, when weights are applied on that particular wire, and weight is applied on that ice cube, so actually what happens here? First thing is there, when pressure is applied, then ice melts. When pressure is applied, ice melts, and when pressure, ice melts, and wire passes through it. When pressure is applied, then ice melts and wire passes through it. But second, when pressure is removed, then liquid or that particular water reconverts into ice. So two things are happening. When pressure is applied, ice melts and wire passes through that particular slab, and when pressure is removed, then whatever liquid is formed, that liquid again reconverts into ice. But why this happens? So third point is there, Here it is happening due to the when pressure is applied. when pressure is applied when pressure is applied, melting point of ice melting point of ice melting point of ice decreases. Melting point of ice decreases, that means it goes below 0 degree Celsius. Decreases means it goes below 0 degree Celsius. Therefore at 0 degree Celsius there will be water. Water is formed. So melting point decreases, it will go below to 0. So at 0 degree Celsius there will be water. And fourth point is there, when pressure is removed, then melting point of ice is restored. That means it will become 0 degree Celsius. So again at 0 degree Celsius water gets converted into ice, and this is happening immediately. So actually what happens when pressure is applied, then ice melts and a wire passes through that particular ice. When pressure is removed, that is whatever molten ice, that ice again freezes and it gets converted into that particular molten ice. That means water, it get reconverted into ice. Water get converted. When pressure is removed, liquid water again reconverts into the ice. But for that, two reasons are there. When pressure is applied, melting point of ice decreases below 0 degree Celsius, and therefore at 0 degree Celsius water is formed. Water will be there at 0 degree Celsius, and when pressure is removed, then melting point of ice is restored. Restored means it is becoming 0 degree Celsius, and then at 0 degree Celsius again water will get freezes. Water freezes. It will get converted into ice. So definition we have to see. What is the definition of regelation? So what is regelation? It is the phenomenon. Regelation is the phenomenon in which ice converts into liquid. Due to applied pressure. When pressure is applied on that ice will get converted into liquid or water, and then that water reconverts into ice once pressure is removed. Water will get converted into ice when pressure is removed. It is called as a regelation. So this is definition of regelation: phenomenon in which ice converts into liquid due to applied pressure and then reconverts into ice once pressure is removed is called as a regelation. And example is there, ice ball. Summer season, whatever ice ball you are eating, so when pieces of that particular ice are pressed together, so melting will take place, and when you are removing pressure, then ice it will form, that water will form ice, and then it will get converted into ice ball. So based on this regelation, there are 2-3 questions. First question is there, and in that use your brain power. In that first question is there, when or what is there in the above experiment. So when you are applying pressure, when your wire is kept on that particular ice slab, and when weights are applied, then why it is not breaking? So reason is here, when pressure is applied, that ice melts and it will get converted into water, and melting point of the ice lowers than 0, it becomes less than 0, and so it will wire will pass. And when pressure is removed, then ice will, or that water will get converted into again ice at 0 degrees Celsius. So melting point is restored. So when wire will pass, again ice will get water will get converted into ice. So that ice slab is not breaking. So next question is there: is there any relationship between latent heat and regelation? So next question is there: is there any relationship between latent heat or latent heat and regelation? So it is, there is the relation between latent heat and regelation. So what is the latent heat? Amount of heat absorbed at constant temperature to convert solid into liquid at constant temperature, it is called as a latent heat. And latent heat of fusion, and another one is there latent heat of vaporization. In that, amount of heat absorbed at constant temperature to convert liquid into its vapors, it is called as a latent heat of vaporization. So these concepts are useful here in regelation also. So next, third question is there. So one question is there related to the sea level. At the sea level, what happens? Melting point of ice, melting point of boiling point of water. At the sea level, boiling point of water decreases. Boiling point of water decreases. So one question is there: what will happen about melting point of solid? What will be the effect on the melting point of the solid? So at sea level, boiling point decreases, boiling point of water decreases, then what will be the effect on the melting point of the solids? So what happens in case of the melting point of the solid? Melting point of the solid at the sea level, melting point will increase. Melting point increases. So next question is there. So we are feeling cold and we are feeling hot. So this question is related to the feeling cold and hot. So why we feel cold and why we feel hot, and is it depending upon body temperature? So atmospheric temperature will be lower than body temperature, it will be less than body temperature, then we are feeling cold. And suppose if atmospheric pressure atmospheric temperature is more than body temperature, then we are feeling hot. So feeling of coldness and hotness depends upon our body temperature. If atmospheric temperature is more than body temperature, we are feeling hot. If atmospheric temperature is less than body temperature, we are feeling cold. So after this, next point we are going to study, and that next point is anomalous behavior of water. Next point is there: anomalous behavior of water. Anomalous behavior of water. So what is anomalous behavior of water? So that one we are going to see, and with the help of Hope's apparatus also we are going to see anomalous behavior of water. So in case of the anomalous behavior of water, before this we have studied expansion and contraction. Before this we have studied expansion and contraction. So expansion means when you are heating any substance, any solid, if you are heating any substance, any solid or any liquid, so its size, length, area, volume. Suppose you will consider a solid, so its length, area, volume, or any substance you will take, its volume will increase or area will increase. When you are heating any substance, its volume or area increases, and when you, it is called as a contraction, expansion. And contraction, when you are cooling any substance, its volume, area decreases, it is called as a contraction. So next point is that anomalous behavior of water. Anomalous behavior of water. So what is anomalous behavior of water? So in case of the anomalous behavior of water, it is the behavior of water which is different from other substances. It is behavior of water. So what happens in case of other substances? other substances, generally when you are heating that substances, expansion takes place. And in case of cooling, when you are cooling any substance, then contraction takes place. But water is behaving different between 0 to 4 degrees Celsius. Water is behaving different between 0 to 4 degrees Celsius. So what happens, that one will see. Suppose between 0 degrees Celsius and 4 degrees Celsius. So if you will heat water, if you will heat water 0 to 4, so actually as compared to the other substances, suppose this one is there water, this one is water, and here another substance, suppose 0 degrees Celsius and 4 degrees Celsius. So if in case of water, generally another substances, what takes place here? Expansion takes place. For another substances, expansion takes place 0 to 4 degrees Celsius. But for water, here contraction takes place. Here contraction takes place on heating, and on cooling from 4 to 0 degrees Celsius. Here water, now instead of contraction, here expansion takes place. Here expansion takes place. And in case of another substances, when you are cooling from 4 to 0 degrees Celsius, here contraction takes place. So if you will compare this one, water with another substances, so any substance, any another substance in that, when you are heating 0 to 4 degrees Celsius, expansion takes place, and when you are cooling from 4 to 0 degrees Celsius, contraction takes place. But water is behaving different. So when you are heating from 0 to 4 degrees Celsius, contraction takes place. Contraction takes place means volume decreases. Volume decreases. And expansion takes place means volume increases. Volume increases. So, and we are knowing one thing, density is equal to mass upon volume. Density is equal to mass upon volume. So when you are heating water 0 to 4 degrees Celsius, contraction takes place. Contraction takes place means volume decreases. Volume decreases means density increases. Volume decreases means density increases. So what you can say, at 0 degrees Celsius, here volume is more. So volume is more. In case of water we are talking, at 0 degrees volume is more. So therefore density is less. Density is less or minimum. So at 0 degrees Celsius, density is minimum, density is less, volume is more, density is less. But at 4 degrees Celsius, what takes place? At 4 degrees Celsius, what takes place? So at 4 degrees Celsius, volume decreases. Volume decreases. At 4 degrees Celsius, volume decreases. When volume decreases, therefore density increases. Density increases. So at 4 degrees Celsius, density increases means density is maximum. So at 0 degrees Celsius, density is minimum, ice floats on water. And at 0 degrees Celsius, density is minimum, ice floats on water. And at 4 degrees Celsius, density is maximum. So water sinks down, or it sinks. Okay, so one thing we are knowing, substances having more density sinks into water, and substances having less density, they float on water. So here in case of another substances, like this behavior is not occurring. So do you understand what you mean by anomalous behavior of water? So at 4 degrees Celsius, density is maximum, density is maximum and volume is minimum. At 4 degrees Celsius, so at 4 degrees Celsius, density is maximum and volume is minimum. At 4 degrees Celsius, density is maximum and volume is minimum. And at 0 degrees Celsius, density is minimum and volume is maximum. Volume is maximum. So this behavior of water is called as a anomalous behavior of water. Okay. So do you understand this one? So in another word we will write. So in case of water, you are heating water 0 to 4 degrees Celsius, contraction takes place. If you are cooling water from 4 to degrees Celsius, expansion 4 to 0 degrees Celsius, expansion will take place. So this behavior of water is called as a anomalous behavior of water. So definition you can tell. Definition: behavior of water between 0 degrees Celsius to 4 degrees Celsius. Between 0 degrees Celsius to 4 degrees Celsius. Different from another substances that is on heating 0 degrees Celsius to 4 degrees Celsius, contraction maximum 4 degrees Celsius, 0 degrees Celsius to 4 degrees Celsius contraction, and cooling, and on cooling from 4 degrees Celsius to 0 degrees Celsius, expansion is called anomalous behavior of water. Anomalous behavior of water. So anomalous behavior of water. And in case of anomalous behavior, 2 points you have to remember. 2 points. Which 2 points? First one is there at 0 degrees Celsius. So at 0 degrees Celsius, volume is maximum. So density is minimum. Density is minimum. Volume is maximum, density is minimum. So therefore ice floats on water at 0 degrees Celsius. At 0 degrees Celsius. So again, at 4 degrees Celsius, what is there? So at 4 degrees Celsius, volume is minimum. Volume is minimum. Volume is minimum. Therefore, also density is maximum. Density is maximum. Therefore, at 4 degrees Celsius, water sinks down. Water sinks down. Water sinks down. Okay. So this is anomalous behavior of water. So these things you have to remember. Another thing we are going to study about water, and with the help of graph we'll study. With the help of graph.